Hey guys, we're back with Chapter 6, Manners of Sex. Today we're going to be discussing sections 2 and 3. So section 2 is traits inherited on sex chromosomes, and section 3 is sex-limited and sex-influenced traits. All right, so you guys ready? Let's get going. Hi, Ripley. So first thing first, let's talk a little bit about sex-linked traits. Now, as we already said, sex-linked traits are traits located on sex chromosomes. There are Y-linked traits, which means that the genes for those are located on the Y chromosome, like SRY. And there are also X-linked traits that are located on the X chromosome. And Y-linked traits are very, very rare simply because there's not as many genes on the Y chromosome, and they can only affect males, whereas X-linked traits can affect males or females. And those are more common, plus there are more genes on the Y chromosome. So we generally talk more about X-linked traits, but please do keep in mind that Y-linked traits do exist. Males are hemizygous for X-linked traits, meaning that since males only have one X chromosome, because remember, chromosomally, males are XY. They only have one X chromosome, so whatever allele for their genes that is located on that one X will be expressed. So they either have that trait or they don't, in terms of like disorders. They either show the disorder or they don't. Females, on the other hand, since we have two X's, then we can be, let's say it's a recessive trait that we're tracking, like hemophilia. Then we can either have two dominant X's and be completely normal, no hemophilia whatsoever. We can be carriers, meaning we have a dominant and a recessive, one dominant on one X, recessive on the other. And that, when we talk about being carriers, it means that we do not show the trait of the recessive X, but we carry it and we can pass it on to our children. Or females can be homozygous recessive, so they can have two recessive X's or two recessive alleles on their X's, in which case they will express that recessive disorder. And as you kind of see here on this picture, males have one X and one Y. The only way you can get sons is by having the Y passed on from the father. So the father does not pass on the X chromosome to his sons. He passes on his Y chromosome. That's how the sons get their Y chromosome, from their dad. Mom, here we see she's a carrier. Mom has a 50% chance of passing on a normal X and a 50% chance of passing on the affected X. All right. So let's talk a little bit about what X-linked recessive inheritance would look like. Since males only have one X chromosome, whatever their allele is for that particular gene, they will express it. So if they have the dominant allele, they will show the dominant trait. If they have the recessive allele, they will show the recessive trait. Simple as that. They either have it or they don't. But females, we have two X's, and this is what we were talking about on the previous slide, is that we tend to see a little bit more possibilities. Again, males, either they have it or they don't. But in females, if they have two dominant alleles, they are normal. If they have one dominant, one recessive, they are carriers, meaning that they do not express that trait, but they carry the allele for it and they can pass it on. Or they can have two recessive alleles and thus show the recessive trait. So males have it or don't. Females have it, don't have it, or are carriers for it. Now, here are some examples of some X-linked recessive traits. First one is ichthyosis, and that's this picture on the bottom right. So the skin is covered in this rough, brown, scaly texture, and it's due to an enzyme deficiency. Now, specifically, this enzyme would remove the cholesterol from the skin cells and from the skin layers, but since it's an enzyme deficiency, the enzyme isn't working, and thus it can't remove the cholesterol from the skin. So it kind of builds up, and that's why you get these rough, scaly textures. Hemophilia A, and what this is the blood doesn't clot. So there's a missing protein that helps the blood to clot. So if you get a cut on your arm, it'll bleed for a little bit, but eventually the bleeding will stop and you'll form a scab. What a scab is dried up, coagulated red blood cells, and some white blood cells mixed in. But what happens is they form this sticky solution that allows them to adhere to each other, thus filling in the wound until new skin cells can be made. But so with hemophilia, they can't clot their blood, so it'll keep bleeding and bleeding and bleeding. And this can be very, very dangerous for someone because they have a much higher chance of bleeding to death from something that normally wouldn't affect anyone. Color blindness, typically or specifically red-green color blindness, this is when someone cannot really see the colors red and green. So they turn, or my understanding of it, I'm not colorblind, my understanding of it is that they appear as shades of gray because they just don't see those exact wavelengths of light. This affects about 8% of European males, about 4% of African males, and about 0.04% of all females. So you see this big difference between males and females, and that's simply because, like we said, males either have it or they don't. Females have it, don't have it, or are carriers for it. Duchenne muscular dystrophy, and what this is, it's a progressive wasting of the muscles. So you start losing muscle control and muscle coordination. It usually begins in the legs and then kind of works its way up. So that's this picture on the left-hand side, loss of muscle mass, inflammation, fibrosis, and this results in being unable to walk and being forced to be in a wheelchair. As it goes higher, it weakens the diaphragm, which means that the individual has much harder time breathing. And then it starts affecting the signals to the heart, and which results in decreased heart function, cardiomyopathy, which then leads to heart failure. It is a fatal disease or disorder. Lesch-Nyhan syndrome, that's what this individual up here in the top right has. And there's a very particular reason why they are strapped down as severely as they are. First off, one of the big symptoms is very, very severe mental impairment. So mental development is stunted very early on, and it leads to very, very severe learning difficulties and mental awareness. But the reason why this individual is tied or is strapped down, you can see all the different straps on him, is because another big effect of or symptom of Lesch-Nyhan is self-mutilation. There have been cases of people with Lesch-Nyhan. You know how like you might on a nervous tick just kind of like chew and bite your nails? What if you bit them all the way down to the point where you're biting the skin and the nail itself, the entire nail is coming up? Well, there are plenty of cases of that, or them scratching themselves until they bleed, or things of that nature. So that's why a lot of times people with Lesch-Nyhan, they might be strapped down like that. It's not that their caretakers are trying to be cruel, is that they're trying to prevent the self-mutilation. All right, let's talk about some X-linked dominant inheritance. So X-linked dominant is we definitely do see a different trend in expression than we do with recessive, obviously. X-linked dominant conditions are expressed in both males and females. With the recessive, we tend to see more males than females expressing that trait. But in a dominant X-linked trait, we tend to see it more or less pretty equally affected in males and females. Now, these traits tend to be a lot more severe in males, though. So what that means is, yes, you can see it in both males and females pretty equally, but the cases in males are more severe. And I can talk about a little bit about why that is later. So again, males, they have one X, either they have the affected X or they don't. So either they have the trait or they don't. In this case, with females, they either have two dominant alleles, in which case they will have it. They have two unaffected or recessive alleles, they will not have it. And if they're heterozygous, then they have one dominant allele and one recessive. Now, because they still have the one dominant allele, they will still show the trait. But the fact that they are heterozygous at that point, it can actually lessen the severity of it, which is why females generally aren't, why the condition is more severe in males and not always as severe in females, because heterozygous females, it tends to decrease the severity of it due to the presence of that recessive allele. Because of how severe these can be, it does often lead to high rates of miscarriage in male offspring. So there's a much higher chance if a woman is carrying a son who would have one of these X-linked dominant disorders, there's a much higher chance that she can have a miscarriage from it, sorry. So here are some examples. Amelogenesis imperfecta, and that's what we see up in this top left picture, and it leads to abnormal teeth enamel. So the teeth don't form properly, the enamel doesn't form properly, and it can lead to a lot of mouth problems and mouth diseases and disorders. Incontinentia pigmenti, which is what we see on here on the left, sorry, right, here on the right. So there are swirls of skin pigment in newborn females. However, again, that's just what we see in females, specifically in heterozygous females. The more severe cases that can occur in some females as well as males are pus-filled vesicles, and that's these, like right here, what you see there, those pus-filled bumps. Lesions that can become warty, brown splotches, and they don't go away. They're there for life. It can affect the development of the teeth. It can also result in bald patches around the body, on the head, not to just talking about the whole head, but maybe like this spot right here. Because this does have a lot of associated health problems with it, a female with this disorder, even if it's the less severe version, she will miscarry any pregnancy about 25% of the time. And the next one we know as CGH, or a congenital generalized hypertrichosis. And that's a picture of this woman down at the bottom left. What this does is it produces many, many extra hair follicles all over the body, and it happens in both men and women. And it does cause hair to grow in abnormal places. Now I know some of you are thinking, but Ms. Komar, we're mammals, we have hair all over. Yes, but it's not thick hair all over. And for some people, it just might result in like super hairy arms, but there are cases of it where it actually does cover the entire body, like you see with this woman here. It is thought that this particular disorder could have been the origin of the werewolf myth, because of people who had all this hair covering their entire body. It might have led to the idea of the werewolf. Even today, there is a Mexican family with 19 members who have CGH, and sometimes they're referred to as the wolf boy or the wolf girl. They have been a source of study for the inheritance of CGH, as well as looking at the different varieties of it, meaning the different expressivities, how you can have just like maybe thicker facial hair on the bottom part of your face and thicker arm hair or back hair versus the entire body being covered. The mutant gene present in CGH is atavistic, which means that it was present in an ancestral species. So an ancient ancestor of humans had this as well, had a version of this mutated gene. And we actually know this because we do see a similar version of this gene in chimpanzees. Now, yes, chimpanzees are hairy naturally, but there have been cases of chimpanzees who have much, much denser hair. And even if you notice, there are places on a chimpanzee where there's not as much hair, like around the actual face. But what we've noticed is that there's a version of this that also affects chimpanzees. And that version of their gene is very, very similar to our version of the gene. And that tells us that it likely came from an ancient ancestor of us and chimps. All right. Let's talk about sex-limited traits. So these are sex-limited traits. And when we talk about sex-limited, we mean that they will affect one sex versus the other. Usually, again, there's always exceptions. Now, these might be sex-linked, meaning on the sex chromosome, but actually a lot of these are autosomal. We just don't see them expressed in one sex like we do in the other. So for instance, beard growth, like these two fellows with the crazy beards on the bottom right. Now, yes, someone will tell me, but Ms. Komar, there are women out there who can grow beards. Yes, but how many of them can? Like, how many of them can grow a beard like that? There are exceptions. There are mutations that can allow some women to grow actual beards. But for the most part, most women are not able to. Yes, we do have some hair there. We are mammals, but we cannot grow an actual beard. And this particular gene is located on an autosome. So it's not even on the X versus Y chromosome, but we only see it being expressed in one of the sexes typically than we do in the other. Breast size. I hate to be the bearer of bad news, but guys have breasts too. They just don't swell up with fatty tissue like females do. After all, guys have nipples, right? So guys do have breasts. They do have some breast tissue, which is why it is possible for guys to have breast cancer. It is not that common for guys to have breast cancer, but it can happen. And it is more common in women because genes that form our breasts in terms of increasing the amount of breast tissue and fatty tissue and the mammary glands are more active in female. So we do tend to see higher rates of breast cancer in female because we have more genes that are affecting the growth of our breasts. Milk production, again, guys, you got nipples, but guys cannot lactate. They have the gene, but the gene is not turned on because they are missing the development of the mammary glands and the breast tissue that would support milk production. Preeclampsia. This is a sudden increase in blood pressure that can be inherited from the father, but it only affects women because they get pregnant. So yes, males can have the gene for preeclampsia, but they will never show up because they can't get pregnant. Preeclampsia is a particular blood pressure condition that occurs during pregnancy. If you don't get pregnant, you can't show it. You cannot show this particular condition. So even though a woman can get the gene from her father, only she will show it, and even then she'll only show it if she ever gets pregnant. All right, now sex influence ones. These are traits that we see in both sexes, male and female, but we see that they are different, meaning that in one of them, you see a much more dominant effect, and in the other sex, a more recessive effect. And it's simply because of hormonal differences. So there is pattern hair loss. There's a gene for pattern hair loss. A lot of times you hear it as male pattern hair loss, and that's just simply because, or male pattern baldness. But that's simply because of the larger effect we see in males. So here you can see, starts thinning, starts receding, thinning more, and then you got a top head that is bald. As opposed to females, females can have the same version of this gene, the exact same version, but look, it tends to be less severe. The hair thins, might have some small bald spots, but very, very different results. And that's just because it's more recessive in females and more dominant in males because of hormonal differences. The presence of our sex organs like ovaries versus testes do change the amount of certain hormones in our bodies, estrogen and progesterone versus testosterone and dihydrotestosterone. So because of these different hormone levels, they actually affect the expression of these genes as well. So even though it's the same gene, we see it more dominant in males and more recessive in females because of how the hormones affect the gene expression. All right, so that's it for sections 2 and 3. I hope this helped you guys to kind of understand what's going on a little bit more. If you have questions, hit me up in our Google Classroom or through email. In the meantime, you guys, take care of yourselves, stay safe, stay awesome, stay curious, and I'll talk to you guys later. All right, you guys, take care. Bye-bye.